Hey guys, welcome back. In this lesson we'll take a look at some components from the Sets tab, and they work like the famous Venn diagrams, you know, the ones with the intersecting circles. I've maximized my Grasshopper window for clarity and will not be working in Rhino in this lesson. Let's get started with the Create Set component, which is the first one in the list. So let's open the Sets tab and let's insert our Create Set component. Now this is a very handy component right off the bat, and it requires us a list of primitive data. Primitive data is basically, it can be text, numbers, or booleans. So let's insert a list of text using a panel. And like before, let's insert some animal names. And let's set it to multi-line data, so they all have their own index. Now, this component basically goes through a list and checks all the individual items and outputs an index map of those organized items, let's say. So if I insert my list into the L, and let's insert a panel to the outputs to see what happened. So let me zoom in a little bit. So you see that the component figured out there's only 5 distinct values in my original list, which is the fish, the dog, the mouse, the cat, and the bunny. And the cool thing is that the other output, the M, that's the index map of those items. So all the items that have fish, they got the 0 index. If you compare it with the original list, if I put them side by side, you see that everywhere there's a fish, they've been indexed with a 0. And the next one is the dog, which got index number 1. So every item that is a dog has the 1 as an index, and so forth. So this will be very helpful if you want to remap a certain data structure, as we will see in the next lesson, where I'm going to use this component when we're going to look at tree branch and everything. But I already wanted to give you a preview of this component because it can be very helpful in reorganizing tree structures. Now let's take a look at some other components from the Sets tab. There are 3 components I want to take a look at, which is Set Difference. The next one is Set Intersection. And the last one is Set Union. And those of you that are familiar with the Venn diagrams, you know the logic behind these components. And let me make 2 different lists for these components. Let me just insert some characters for a change. So this will be my list. Now the set difference will basically check 2 sets, A and B, and will spit out the difference between those 2 sets. So if I copy this list one more time, and let me just delete some items. Something like that. So the U output, those are all the items that exist in A minus B. All the values that were in A and B, those got removed from the A list. Now let's move on to our next component, which is the Set Intersection component. Let's use the same list. Now the output again, those are the values that are outputted from the U. Those are all the values that exist in list A and in list B. And the cool thing is that you can actually add more lists to this input by hitting the plus sign. So you can add as much lists as you want. And the nice thing is that it will only spit out unique values that exist in all 3 or all 2 lists, let's say, depending on how much inputs you have. Let's continue to the last component, which is the set union. And let's use the same list again. And let's see what the output is. And those are all the distinct values that happen in both lists, basically. There are no duplicates, for instance, because if you look at the A and B list, I have the capital A in both lists, but it only outputted God once. Those values from the U, those are all the values that are unique, but exist in both lists, let's say. So the next couple of components I want to take a look at, let's move a little bit to the top, is the find member or member index, which is located here. And this component will find a member in a set and also outputs the index where it was located. So let me copy one list over again. Say this list. Let me insert some more characters. So something like that. Now we need to insert an item we want to search for. So let's say I want to search for the percentage sign. If it found an occurrence, it tells me where it is located. So it's located at index 3, which makes sense because it's located here. And the n tells me how many times that value got repeated, which is only once. But let's say if I insert a couple of more percentage signs, you see that now it tells me, okay, besides at location 3, it also is located at location 7 and location 13, the index in the other list. And if I connect the panel to the n, you see that now it tells me instead of 1, it tells me, okay, this item occurs 3 times in the S list, in the input list. Which can be very helpful for you to find occurrences of a member in a certain set. Now let's take a look at the next component I want to show you, which is also located in sets. And it's called replace members. And let's use the same list. And let's say I want to replace those percentage items with another item, let's say. So if I insert this one into the F, which is the item you want to search for to replace, and the R, that's an item you want to replace it with. So let's say I want to replace it with some equal signs. You see that now my output list, all the percentage signs, they got replaced with equal signs. This can be also very helpful if you want to replace a certain set of text or strings or numbers with some other piece of text or string. Now the last 2 components I want to take a look at are find similar member and delete consecutive. And delete consecutive basically deletes items that are the same. Let me show you if or better, let's use the animal example, which we used in the beginning. And let's see the output. You see that it deleted consecutive items. So if the next item in the list is the same as the previous one, it will get removed from the list. Now let's take a look at the find similar member component, which is also a very useful component. So let's insert our list. And the D, that's the item you want to search for. And the nice thing of this component is even if you make slight spelling mistakes, it will still find the item you're looking for, or find a member that's similar to that one. So the H is the member it found, which is dog, only written with a capital, and the small I is the index. So the only thing is that it will only find the first occurrence. But let's say if I write it a little different, something like this, it will still retrieve the dog item. And the same goes for if I write, for instance, fish, but I make some spelling mistakes. It will still recognize, like, okay, you're looking for, the closest member you're looking for is fish, which is located at index 0. And this component can also be very useful for you if you want to look for certain members in a set, but you're not really sure the spelling of it. It will still locate a member that's quite similar to the one you're looking for. Now this brings us to the end of this lesson, and also to the end of this part of the course. Because in the next lessons, I'm going to talk about data structures. So we're not going to look at flattened lists, but actually we're going to take a look at data tree structures, how that data is organized and how we can manipulate those lists and those data trees using more components from the sets tab, and mainly under the tree tab, which has some really interesting components, which we can do some more complex data operations. Thank you for watching, and I'll see you in the next lesson.